What if I told you that every atom in your body was forged in the nuclear furnace of a dying star billions of years ago? That you are literally made of stardust, carrying within your DNA the chemical signature of cosmic explosions that happened before Earth even existed. And here's what will absolutely blow your mind. The calcium in your bones, the iron in your blood, the oxygen you're breathing right now. All of it was created when massive stars collapsed and exploded, scattering their atomic contents across the universe like cosmic seeds of life itself. But that's just the beginning of our journey today. We're going to take the most comprehensive tour of everything that exists, from the quantum foam that might be bubbling beneath reality itself, all the way to the largest structures in the universe that span billions of light years. And by the end of this cosmic adventure, you'll understand not just where you came from, but why your existence is one of the most improbable and magnificent things that has ever happened in the known universe. Before we launch into this mind-bending journey, hit that like button if you're ready to have your perspective on reality completely transformed. And don't forget to subscribe, because we're going to be diving deep into the most fascinating mysteries of existence. Also, drop a comment and let me know what country you're watching from and what time it is where you are. I love seeing our global community of cosmic explorers come together from all corners of our pale blue dot. The story begins 13.8 billion years ago with something so bizarre that even our best physicists struggle to wrap their heads around it. Picture this: everything you see, everything you know, every galaxy containing billions of stars, all of it once existed in a space smaller than the period at the end of this sentence. The Big Bang wasn't an explosion in space. It was an explosion of space itself, creating not just matter and energy, but the very fabric of time and spacetime. Here's where it gets really weird. In 1965, two scientists named Arno Penzias and Robert Wilson were trying to eliminate mysterious background noise from their radio antenna at Bell Labs. They couldn't get rid of this persistent static no matter what they tried. They even cleaned pigeon droppings off their equipment, thinking that might be the source. What they had accidentally discovered was the cosmic microwave background radiation, the afterglow of creation itself, still echoing through the universe after nearly 14 billion years. Think of it like this. Imagine you're in a completely dark room, but you can still feel the warmth from a fireplace that was extinguished hours ago. That's essentially what Penzias and Wilson detected, the leftover heat signature from when the universe was a blazing hot, dense plasma, cooling and expanding into the cosmos we see today. This discovery earned them the Nobel Prize and gave us our first direct evidence that the Big Bang actually happened. But here's what's truly mind-blowing about those first moments. In the first second after the Big Bang, the universe went through a phase called cosmic inflation, expanding faster than the speed of light. Now wait, didn't Einstein tell us nothing can travel faster than light? That's true for objects moving through space, but space itself can expand at any speed it wants. During inflation, the universe grew from subatomic to astronomical size in a tiny fraction of a second. Imagine a grain of sand suddenly becoming larger than a basketball. This rapid expansion solved one of cosmology's biggest puzzles. When we look out into space in opposite directions, we see regions of the universe that are so far apart that light hasn't had enough time since the Big Bang to travel between them. Yet somehow, these regions have almost exactly the same temperature. How is that possible? It's like walking into two completely separate rooms that have never been connected and finding they're both set to precisely the same temperature on their thermostats. The answer is cosmic inflation. Before that explosive expansion, these now distant regions were once close enough to reach thermal equilibrium, the same temperature. Then inflation stretched space so rapidly that these regions were suddenly billions of light years apart, but they retained their synchronized temperature like a cosmic memory of their shared past. Now, during those first crucial seconds, something remarkable was happening. The universe was cooling from trillions of degrees to mere billions. And as it cooled, the fundamental forces that govern reality began to separate and take shape. In the extreme heat of the earliest moments, all forces were unified into one superforce. But as temperatures dropped, first gravity separated, then the strong nuclear force, then the electromagnetic and weak nuclear forces split apart. Think of it like water freezing into ice. As the temperature drops, the loose, fluid nature of water suddenly becomes rigid and crystalline. Similarly, as the universe cooled, the unified superforce froze into the four distinct forces we know today. This process, called spontaneous symmetry breaking, essentially wrote the laws of physics as we know them. The universe was literally deciding how it was going to behave for the next 13.8 billion years. Within the first few minutes, something extraordinary happened that would determine the chemical composition of everything that would ever exist. The universe had cooled enough for protons and neutrons to stick together, forming the first atomic nuclei in a process called Big Bang nucleosynthesis. In just about 20 minutes, roughly 75% of all normal matter became hydrogen, 25% became helium, and tiny traces of lithium and beryllium were formed. Here's what's absolutely incredible about this. Those same ratios of hydrogen and helium that were created in those first 20 minutes are still what we observe in the universe today. Every star, every galaxy, every cloud of gas floating in intergalactic space still carries this chemical signature from the universe's birth. It's like finding a manufacturer's stamp on every single thing that exists, proving they all came from the same cosmic factory. But here's where our story takes a dramatic turn. For the next 380,000 years, the universe was completely dark and opaque. It was filled with a hot plasma where electrons, protons, and photons were constantly colliding and scattering. Light couldn't travel more than a tiny distance before being absorbed or scattered, making the entire universe like being inside a glowing fog bank. Then, as the universe continued to expand and cool, it reached a critical temperature of about 3,000 Kelvin. Suddenly, electrons and protons combined to form the first neutral hydrogen atoms in an event cosmologists poetically call recombination. For the first time in cosmic history, photons could travel freely through space. The universe became transparent, and light could journey across vast distances unimpeded. This moment, called the surface of last scattering, is actually what Penzias and Wilson detected with their antenna. Those microwaves hitting their equipment were photons that had been traveling through space for over 13 billion years, carrying with them a snapshot of what the universe looked like when it first became transparent. We're literally seeing baby pictures of the cosmos every time we detect this cosmic background radiation. But here's what's going to blow your mind. The universe at this point was remarkably smooth and uniform, with only tiny variations in density from place to place. These variations were so small, less than 1 part in 100,000, that they're like finding ripples on a perfectly calm lake that are smaller than a hair's width. Yet these microscopic ripples would eventually grow into all the structure we see in the universe today. Galaxies, galaxy clusters, superclusters, and the vast cosmic web of dark matter that spans billions of light years. How did such tiny variations create such massive structures? The answer lies in one of the most mysterious substances in the universe, dark matter. Making up roughly 27% of all matter and energy in the cosmos, dark matter doesn't emit, absorb, or reflect light. We know it exists only through its gravitational effects on visible matter and the large-scale structure of the universe. Think of dark matter like an invisible scaffold. Those tiny density variations we talked about? In regions where dark matter was even slightly more concentrated, its gravity began pulling in more dark matter and regular matter from the surrounding area. Over millions of years, these gravitational seeds grew into massive halos of dark matter, creating gravitational wells where ordinary matter could collect, and eventually form the first stars and galaxies. This brings us to one of the most exciting recent discoveries in cosmology. In 1998, two independent teams of scientists, one led by Saul Perlmutter and another by Brian Schmidt and Adam Rees, were studying distant supernovae to measure how the expansion of the universe was slowing down over time. Everyone expected to find that gravity was gradually putting the brakes on cosmic expansion. Instead, they discovered something that shocked the scientific world. The expansion of the universe is actually speeding up. Galaxies are flying away from each other faster now than they were billions of years ago. This discovery earned them the 2011 Nobel Prize in Physics and revealed the existence of dark energy, a mysterious force that makes up about 68% of the universe and is literally pulling space apart at an accelerating rate. Here's how mind-bending this is. Imagine throwing a ball up in the air, and instead of gravity slowing it down and pulling it back, the ball starts accelerating upward, flying faster and faster into the sky. That's essentially what's happening to the universe itself. Some unknown form of energy is overpowering the gravitational attraction between galaxies and driving them apart at an ever-increasing pace. What could dark energy possibly be? The honest answer is we don't know, and it's one of the greatest mysteries in modern physics. Some theories suggest it's a property of space itself, that empty space contains a small but constant amount of energy that becomes more apparent as the universe expands and creates more space. Others propose it might be caused by extra dimensions of reality that we can't directly perceive, or that our understanding of gravity itself needs to be completely revised. This uncertainty brings us to a humbling realization. Despite all our scientific progress, we have no idea what 95% of the universe is made of. We've identified dark matter and dark energy as the dominant components of reality, but we can't directly observe or fully understand either one. It's like realizing that everything you thought you knew about your house actually applies to just the furniture, while the walls, foundation, and roof are made of completely mysterious materials. But let's get back to the stuff we can see and understand, the ordinary matter that makes up stars, planets, and us. After those first few 100,000 years of cosmic darkness, gravity began its slow work of pulling matter together into the first structures. Computer simulations show us that dark matter formed vast web-like networks throughout the universe, with dense nodes connected by filaments and separated by enormous voids. At the intersection points of this cosmic web, where dark matter was most concentrated, the first stars began to form. These weren't like the stars we see today. They were massive, probably 100 to 1,000 times more massive than our sun, and they burned incredibly hot and bright. Because the universe contained only hydrogen and helium at this point, these population 3 stars, as astronomers call them, had no heavy elements to help them radiate away heat efficiently, so they had to be enormous to maintain the nuclear fusion reactions in their cores. These first stars lived fast and died young, burning through their nuclear fuel in just a few million years before exploding as supernova. But their death was the universe's gain, because it was in the nuclear furnaces of these stellar giants that the first heavy elements were forged. Carbon, oxygen, silicon, iron, all the elements essential for rocky planets and life itself, were created through nuclear fusion in stellar cores and then scattered into space when the stars exploded. Here's where the connection to your own existence becomes profound. The physicist Carl Sagan famously said, "We are made of star stuff," and he was being completely literal. Every atom in your body, heavier than hydrogen and helium, was manufactured in the core of a star or during a stellar explosion. The carbon atoms forming the backbone of your DNA, the calcium in your bones, the iron in your hemoglobin, all of it was forged in nuclear reactions that required temperatures of hundreds of millions of degrees. But it gets even more amazing. Different elements are created through different stellar processes. The lighter elements like carbon and oxygen are produced during a star's normal lifetime through fusion reactions. But elements heavier than iron require even more extreme conditions. They're primarily created during the explosive death of massive stars or in the collision of neutron stars. Events so violent they can briefly outshine entire galaxies. In 2017, scientists detected gravitational waves from the collision of two neutron stars in a galaxy, 130 million light-years away. For the first time, we were able to observe the creation of heavy elements like gold, platinum, and uranium in real time. The collision produced more than 200 Earth masses worth of pure gold, scattered into space to eventually become part of new star systems, planets, and potentially living beings. This means the gold in your jewelry, the platinum in your catalytic converter, and the uranium powering nuclear reactors all came from cosmic catastrophes billions of years ago. You're not just made of star stuff, you're made of stellar explosion stuff, neutron star collision stuff, cosmic catastrophe stuff. Your existence required not just one star to live and die, but multiple generations of stars, creating and distributing the elements necessary for planets and life. The scale of this cosmic recycling program is staggering. Our Milky Way galaxy contains roughly 400 billion stars, and over its 13 billion-year history, countless generations have lived, died, and enriched the interstellar medium with heavier elements. Our Sun is actually a third-generation star, meaning it formed from material that had already been processed through at least two previous generations of stellar furnaces. This is why our solar system contains rocky planets like Earth. Earlier generations of stars had to live and die to create the silicon, iron, and other heavy elements that make up terrestrial worlds. The formation of our solar system 4.6 billion years ago is itself a remarkable story of cosmic construction. It began when a nearby supernova explosion sent shock waves through a cloud of gas and dust, compressing it enough to trigger gravitational collapse. As this solar nebula contracted, it began spinning faster, flattening into a disk with our newborn sun at the center and smaller clumps of material orbiting around it. Through a process called accretion, dust grains stuck together to form pebbles. Pebbles clumped into boulders. Boulders combined into planetesimals, and planetesimals collided and merged to form the planets we know today. The inner, rocky planets formed in the hot region close to the sun, where only materials with high melting points could remain solid. The outer gas giants formed in the cold outer reaches, where water could freeze into ice, providing the solid material needed to build cores massive enough to gravitationally capture thick atmospheres of hydrogen and helium. Earth's early history reads like a cosmic disaster movie. For the first few 100 million years, our planet was constantly bombarded by asteroids and comets in an event called the Late Heavy Bombardment. The impacts were so intense that they repeatedly sterilized the surface and boiled away any oceans that might have formed. Some of these impacts were so massive, they melted the entire planet's surface, creating global magma oceans that took thousands of years to solidify. But one of these impacts turned out to be fortunate for us. About 4.5 billion years ago, a Mars-sized object called Theia slammed into the early Earth at just the right angle and speed. Instead of destroying our planet, this collision ejected enormous amounts of material into orbit, which eventually coalesced to form the Moon. This impact also gave Earth its 23.5-degree axial tilt, which creates our seasons and the rapid rotation that gives us our 24-hour day. The Moon's formation was crucial for the eventual emergence of life. Its gravitational pull creates tides that helped mix the early oceans and may have provided the energy gradients necessary for the first chemical reactions that led to life. The Moon also stabilizes Earth's axial tilt, preventing chaotic climate swings that would make it difficult for complex life to evolve. Without our unusually large Moon, Earth might be a very different and possibly lifeless world. Now, here's where our cosmic tour takes an absolutely mind-blowing turn. Despite all the violence and chaos of Earth's early history, somehow, somewhere around 3.8 billion years ago, something extraordinary happened. Non-living chemistry became living biology. In some warm tide pool, hydrothermal vent, or perhaps in space itself, molecules began organizing themselves into self-replicating patterns that could grow, reproduce, and evolve. The origin of life remains one of science's greatest unsolved mysteries, but we're beginning to understand some of the key steps. The building blocks of life, amino acids, nucleotides, and other organic molecules, have been found in meteorites and can be created in laboratory experiments that simulate early Earth conditions. The famous Miller-Urey experiment in 1953 showed that passing electrical sparks through a mixture of methane, ammonia, water, and hydrogen, simulating lightning in Earth's early atmosphere, could produce amino acids spontaneously. But getting from organic molecules to living cells required something much more sophisticated: the development of self-replicating molecules that could store and transmit information. RNA, which can both store genetic information like DNA and catalyze chemical reactions like proteins, may have been the first self-replicating molecule. This RNI world hypothesis suggests that life began with RNA molecules that could make copies of themselves, eventually evolving the ability to make proteins and later, the more stable DNA. Here's what's absolutely incredible about this process. It only had to happen once. Every living thing on Earth, from bacteria to blue whales to you, shares the same basic genetic code and cellular machinery. This strongly suggests that all life on our planet descended from a single common ancestor, sometimes called LUC, the last universal common ancestor. Around 3.8 billion years ago, this microscopic pioneer figured out the trick of self-replication and passed it on to every living thing that would ever exist on Earth. For the next 2 billion years, life remained relatively simple, just single-celled organisms floating in the oceans. But these early microbes were performing one of the most important jobs in Earth's history. Cyanobacteria, sometimes called blue-green algae, evolved the ability to perform photosynthesis, using sunlight to convert carbon dioxide and water into sugar and oxygen. This might not sound revolutionary, but it completely transformed our planet. For nearly 2 billion years, Earth's atmosphere contained almost no free oxygen. The oxygen produced by photosynthesis was immediately consumed by chemical reactions with iron and other materials. But eventually, around 2.4 billion years ago, the oxygen producers overwhelmed the oxygen consumers, and free oxygen began accumulating in the atmosphere for the first time. This event, called the Great Oxidation Event, was actually a mass extinction. Oxygen was toxic to most of the anaerobic organisms that had dominated Earth for its first 2 billion years. From their perspective, photosynthetic bacteria were polluting the atmosphere with a deadly gas. But this oxygen catastrophe set the stage for more complex life forms that could harness oxygen's chemical energy for metabolism. The buildup of atmospheric oxygen also created the ozone layer, which protects the surface from harmful ultraviolet radiation. Before the ozone layer formed, life could only exist underwater or underground. The oxygen revolution made it possible for life to eventually colonize the land and reach the remarkable complexity and diversity we see today. Around 1.8 billion years ago, another crucial innovation occurred: the evolution of eukaryotic cells. These are cells with nuclei and other specialized internal structures called organelles. The prevailing theory, championed by biologist Lynn Margulis, is that eukaryotic cells formed through endosymbiosis, one cell literally living inside another in a mutually beneficial relationship. The mitochondria that power your cells were once independent bacteria that were engulfed by larger cells. Instead of being digested, these bacterial captives began living symbiotically inside their hosts, providing energy in exchange for protection and nutrients. Similarly, The chloroplasts in plant cells were once free-living photosynthetic bacteria. This merger of different organisms into more complex cells was a crucial step toward the multicellular life forms that would eventually evolve into plants, animals, and fungi. For over 1 billion more years, life remained microscopic. Then, around 600 million years ago, something remarkable happened. Complex multicellular organisms suddenly appeared in the fossil record in an event called the Cambrian explosion. In just a few tens of millions of years, a blink of an eye in evolutionary time, most of the major groups of animals that exist today evolved, including the first organisms with eyes, shells, and sophisticated nervous systems. What triggered this explosion of complexity and diversity? Several factors likely contributed. Rising oxygen levels reached a threshold that could support larger, more active organisms. The evolution of predator-prey relationships drove an evolutionary arms race, and the development of sexual reproduction increased genetic diversity and accelerated evolution. The Cambrian explosion marked the transition from a world dominated by simple, microscopic life to the complex ecosystems we see today. But life's journey from the oceans to the land was another epic adventure. Moving from water to air required solving numerous engineering challenges. Developing ways to support body weight against gravity, extracting oxygen from air instead of water, preventing dehydration, and reproducing without an aquatic environment. Plants were the pioneers, developing root systems, waxy cuticles, and pores called stomata to regulate gas exchange. Animals followed, evolving lungs, legs, and eventually, sophisticated circulatory and nervous systems. The colonization of land opened up entirely new ecological niches and drove another burst of evolutionary innovation. Forests grew and created new habitats. Insects evolved and became the most diverse group of animals on the planet, and vertebrates diversified into fish, amphibians, reptiles, birds, and mammals. The story of life became increasingly complex and interconnected, with organisms evolving intricate relationships of competition, cooperation, and dependence. Throughout this 3.8 billion year evolutionary journey, life had to survive multiple mass extinction events. The fossil record shows at least 5 major extinctions that eliminated 50% or more of all species. The most famous is the asteroid impact 66 million years ago that ended the age of dinosaurs. But the worst was the Permian-Triassic extinction 252 million years ago, which wiped out 96% of marine species and 70% of terrestrial vertebrates. Each mass extinction was followed by adaptive radiations, where surviving species diversified to fill empty ecological niches. The extinction of non-avian dinosaurs, for example, opened up opportunities for mammals to diversify from small, nocturnal creatures into the vast array of forms we see today, including the lineage that would eventually lead to humans. Now, here's where our cosmic tour becomes deeply personal. About 7 million years ago in Africa, something unprecedented happened in Earth's 4.6 billion year history. A particular lineage of primates began evolving larger brains, more sophisticated tools, and complex social behaviors that would eventually lead to language, culture, and consciousness. The human story is incredibly recent in cosmic terms. If Earth's entire history were compressed into a single year, humans would appear in the last few minutes before midnight on December 31st. What makes human evolution so remarkable isn't just our intelligence, but the speed at which our brains grew. In just a few million years, our brain volume tripled from about 400 cubic centimeters to 1,400 cubic centimeters today. This rapid brain expansion came with costs. Human babies are born extremely helpless compared to other mammals because their heads are already at the maximum size they can fit through the birth canal. Our large brains also consume about 20% of our total energy, a huge metabolic investment that only pays off if intelligence provides significant survival advantages. The development of language was perhaps the most crucial innovation in human evolution. Language allowed us to share complex information, coordinate group activities, and most importantly, accumulate knowledge across generations. Unlike other animals, humans can learn not just from their own experience, but from the accumulated wisdom of thousands of previous generations. This cultural evolution began accelerating exponentially once we developed writing systems about 5,000 years ago. The agricultural revolution around 10,000 years ago marked another turning point in human history and Earth's story. For the first time, a single species began deliberately modifying the planet's surface on a massive scale. We cleared forests, diverted rivers, domesticated plants and animals, and created permanent settlements. Agriculture allowed human populations to grow from a few million hunter-gatherers to the 8 billion people alive today. But here's what's truly mind-bending about our current moment in cosmic history. We've become the first species on Earth capable of understanding our own place in the universe. We can trace our ancestry back through millions of years of evolution, billions of years of Earth's history, and all the way back to the Big Bang itself. We've decoded the structure of DNA, mapped the human genome, and can now read the genetic story written in every living thing. We've also become a geological force. The Anthropocene epoch marks the first time in Earth's 4.6 billion year history that a single species has become powerful enough to alter the planet's climate, chemistry, and biology on a global scale. We're currently causing the 6th mass extinction in Earth's history, but we're also the first species capable of understanding what we're doing and potentially preventing it. Even more remarkably, we've begun extending our senses far beyond our planet. Our telescopes can observe galaxies billions of light years away, showing us the universe as it existed when it was young. Our particle accelerators can recreate conditions that existed microseconds after the Big Bang. Our space probes have visited every planet in our solar system and detected thousands of planets orbiting other stars. This brings us to one of the most profound questions in science. Are we alone? The Drake equation, formulated by astronomer Frank Drake in 1961, attempts to estimate the number of communicating civilizations in our galaxy by multiplying together factors like the rate of star formation, the fraction of stars with planets, the number of planets that could support life, and so on. Depending on the values you plug in, the equation suggests anywhere from one, just us, to millions of technological civilizations in the Milky Way. Recent discoveries have made some terms in the Drake equation much more optimistic. The Kepler Space Telescope and other planet-hunting missions have revealed that planets are incredibly common. Nearly every star has at least one planet, and many have planets in the habitable zone where liquid water could exist. We've found planets around red dwarf stars, which make up 75% of all stars and could remain stable for trillions of years, far longer than our sun's expected 10 billion year lifetime. We've also discovered that life on Earth exists in environments once thought impossible, in boiling hot springs, in highly acidic or alkaline conditions, in extremely salty water, and even in radioactive waste. These extremophiles have expanded our understanding of where life might be possible and suggest that habitable zones around stars might be much broader than we previously thought. The search for extraterrestrial life is happening on multiple fronts. We're listening for radio signals from advanced civilizations, looking for chemical signatures of life in the atmospheres of distant planets, and searching for microbial life within our own solar system. Mars almost certainly had liquid water in its past and may still have subsurface oceans. Jupiter's moon Europa and Saturn's moon Enceladus have liquid water oceans beneath their icy surfaces, kept warm by tidal heating from their giant planet hosts. But here's what's really going to blow your mind about the possibility of extraterrestrial life. If it exists, it almost certainly won't be like us. Life on Earth has been shaped by our planet's specific history. From the particular mix of elements available to the sequence of evolutionary innovations and mass extinctions, life elsewhere would have evolved under different conditions and would likely be biochemically and morphologically completely different from anything we've seen. This raises profound questions about intelligence and consciousness. Are these inevitable outcomes of evolution, or are they rare accidents that might never happen again? We have only one example of technological intelligence, ourselves, making it impossible to know whether intelligence is a common evolutionary strategy or a bizarre fluke that happened just once in the observable universe. The implications of either answer are staggering. If intelligence is common, the universe might be teeming with civilizations far older and more advanced than ours, potentially solving problems we can't even imagine and exploring realms of reality we haven't discovered. If intelligence is rare, then humans might be among the first conscious beings in the universe, capable of contemplating existence itself, a cosmically lonely but incredibly special position. This uncertainty about our place in the universe brings us to some of the most mind-bending questions in modern physics. What we've discussed so far, the Big Bang, stellar evolution, planetary formation, the emergence of life and intelligence, all takes place in what we might call the classical universe, described by Einstein's theories of relativity. But quantum mechanics, developed in the early 20th century, reveals a much stranger reality underlying everything we experience. At the smallest scales, the universe behaves in ways that completely contradict our everyday experience. Particles can exist in multiple states simultaneously until they're observed. They can tunnel through barriers that should be impenetrable. They can be entangled with other particles across vast distances, instantly affecting each other's properties in ways Einstein famously called spooky action at a distance. The famous double-slit experiment demonstrates just how weird quantum reality is. When you fire electrons one at a time through two closely spaced slits toward a detector screen, each individual electron somehow goes through both slits simultaneously and interferes with itself, creating an interference pattern. But if you try to observe which slit the electron goes through, the interference pattern disappears, and the electron behaves like a normal particle going through just one slit. This suggests that reality at the quantum level doesn't exist in definite states until it's observed or measured. Before measurement, particles exist in superposition, all possible states at once. Only when we look does the quantum world collapse into the classical reality we experience. This leads to mind-bending interpretations of quantum mechanics, from the many worlds theory suggesting that every quantum measurement splits the universe into parallel realities, to consciousness-based theories proposing that minds play a fundamental role in creating reality. Here's where quantum mechanics intersects with our cosmic story in unexpected ways. Quantum fluctuations in the vacuum of space during cosmic inflation may have been the seeds that grew into all the structure we see in the universe today. The cosmic microwave background radiation we discussed earlier shows tiny temperature variations that match exactly what we'd expect from quantum fluctuations stretched to cosmic scales by inflation. Even more remarkably, quantum mechanics explains why atoms are stable and why chemistry works. Without quantum effects, electrons would spiral into atomic nuclei, atoms would collapse, and matter as we know it couldn't exist. The very fact that you have a solid body and can think coherent thoughts depends on quantum mechanical principles operating at the smallest scales. But quantum mechanics raises profound questions about the nature of reality itself. Is the universe fundamentally deterministic, with quantum randomness just reflecting our ignorance of hidden variables? Or is randomness built into the very fabric of reality? Does consciousness play a special role in collapsing quantum superpositions? Are there parallel universes where every possible quantum outcome occurs? These questions become even more mind-bending when we consider cosmology. Some theories suggest our entire observable universe might be just one bubble in an infinite multiverse. where different regions have different physical laws and constants. If this is true, the fact that our universe has the precise conditions necessary for stars, planets, and life might not be a cosmic coincidence, but rather an inevitable consequence of there being infinite universes with every possible combination of physical laws. The anthropic principle argues that we observe a universe compatible with our existence, simply because we couldn't exist in a universe with different laws of physics. In universes where the strong nuclear force was slightly weaker, atomic nuclei would be unstable and stars couldn't form. In universes where it was slightly stronger, hydrogen would be rare and stellar evolution would be completely different. The range of physical constants compatible with complexity and life appears to be remarkably narrow. This fine-tuning problem is one of the deepest puzzles in physics. Why do the fundamental constants of nature have values that allow for the existence of stars, planets, chemistry, and biology? Is it pure chance, divine design, or the inevitable result of some deeper physical principle we haven't discovered yet? The multiverse theory provides one possible answer, but it's impossible to test since we can't observe other universes, even if they exist. Speaking of deeper physical principles, modern physics suggests that space and time themselves might not be fundamental features of reality. Just as we now know that solid matter is mostly empty space filled with quantum fields, space and time might emerge from some more fundamental substrate. Some theories propose that reality is fundamentally made of information, with space, time, matter, and energy all being different aspects of the same underlying computational process. The holographic principle, emerging from black hole physics, suggests that all the information in a volume of space can be encoded on its boundary surface. This implies that our three-dimensional reality might be a projection from information stored on a two-dimensional surface, like a cosmic hologram. If true, this would mean that everything you experience, your thoughts, emotions, memories, and physical sensations, is ultimately the result of information processing on the boundary of space itself. These ideas sound like science fiction, but they're serious attempts to reconcile quantum mechanics with general relativity and explain some of the deepest mysteries in physics. Black holes, for instance, appear to destroy information when they evaporate through Hawking radiation, violating a fundamental principle of quantum mechanics. The holographic principle and related ideas might resolve this paradox by showing that information is never truly destroyed, but rather encoded in ways we don't fully understand. This brings us to one of the most ambitious goals in physics, developing a theory of quantum gravity that can describe what happens at the smallest scales of space and time. At the Planck scale, which is about 10 to 35 meters and 10 to 43 seconds, quantum effects become so strong that space and time themselves break down into a foam of quantum fluctuations. Understanding physics at this scale might reveal the true nature of reality and answer questions about what caused the Big Bang and what lies beyond the observable universe. Now, here's where our cosmic tour comes full circle and becomes deeply personal. Everything we've discussed, from the Big Bang to quantum mechanics, from stellar nucleosynthesis to biological evolution, led to this moment where you're sitting here contemplating your place in the universe. The atoms in your body were forged in stellar furnaces billions of years ago. The complex chemistry that powers your cells evolved over 3.8 billion years of evolution. The consciousness that allows you to understand these concepts emerged from millions of years of brain evolution. But here's what's truly remarkable about your existence. You're not just made of stardust. You're the universe's way of knowing itself. Carl Sagan beautifully expressed this idea. The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. Through human consciousness, the universe has evolved the ability to contemplate its own existence, to trace its history back to the beginning of time, and to wonder about its ultimate fate. Think about this for a moment. For nearly 14 billion years, the universe existed without any part of it being aware of the whole. Stars were born and died, Galaxies formed and collided. Planets accumulated and evolved, but none of it was conscious or self-aware. Then, in just the last few million years on one small planet, the universe developed eyes and began to see itself. It developed brains and began to think about itself. It developed hearts and began to feel wonder at its own existence. You are literally the universe becoming conscious of itself. When you look up at the night sky and feel a sense of awe, you're experiencing the cosmos marveling at its own beauty and complexity. When you contemplate the vastness of space and time, you're participating in the universe's first attempt to understand its own nature. When you feel connected to something larger than yourself, you're recognizing your fundamental unity with the cosmos that created you. This perspective completely transforms how we think about human significance. Yes, we're tiny specks in an incomprehensibly vast universe. Our entire solar system is less than a light day across in a galaxy that's 100,000 light years wide, in a universe containing hundreds of billions of galaxies. From this view, we seem utterly insignificant, temporary fluctuations in an indifferent cosmos. But here's the flip side that will absolutely blow your mind. We're also the most complex, organized, and sophisticated structures the universe has ever created. Your brain contains roughly 86 billion neurons, each connected to thousands of others through trillions of synapses. The complexity of neural networks in your head exceeds the number of galaxies in the observable universe. You are literally more intricate and organized than anything else we know of in the cosmos. Moreover, the chain of incredibly improbable events that led to your existence is so unlikely that it borders on the miraculous. If the Big Bang had been slightly more or less explosive, the universe would either have collapsed immediately or expanded so rapidly that no structures could form. If the ratio of matter to antimatter had been even slightly different, they would have annihilated each other completely, leaving only photons. If the strong nuclear force were just 2% weaker, atomic nuclei would be unstable and chemistry impossible. The formation of our solar system required the precise timing of a supernova explosion to trigger collapse of the gas cloud that became our sun. Earth needed to form in exactly the right location. Too close to the sun and water would boil away. Too far, and it would freeze. The collision that formed our moon had to happen at just the right angle and speed. Life had to emerge from non-living chemistry, survive multiple mass extinctions, evolve complex cells, develop multicellularity, colonize land, and eventually produce intelligent beings capable of contemplating their own existence. Each of these steps was incredibly improbable. The emergence of consciousness and intelligence may be the most unlikely event in cosmic history. Yet here you are, a conscious being capable of understanding quantum mechanics, contemplating the nature of space and time, feeling love and wonder and curiosity about existence itself. You've won the cosmic lottery, not just once, but thousands of times over. This brings us to what might be the most profound realization of all. You're not separate from the universe. You are the universe. The arbitrary boundary we draw between me and everything else is just a conceptual convenience. The atoms in your body are constantly being exchanged with the environment. The carbon you exhale becomes part of plants, which become part of other animals, which eventually become part of other people. You're not a discrete entity, but a temporary pattern in the ongoing flow of matter and energy that is the universe itself. Even more remarkably, this pattern that is you is incredibly temporary in cosmic terms. Your individual atoms will outlast you by billions of years, eventually becoming part of new stars, new planets, and possibly new forms of life. The calcium in your bones might someday be part of an alien ocean on a planet that hasn't even formed yet. The iron in your blood might power fusion reactions in stars that won't be born for billions of years. You're not just connected to the cosmos. You're a temporary eddy in the cosmic flow, a brief arrangement of stardust that somehow became self-aware. But here's what makes this temporary existence so precious right now. In this moment, you represent the universe's highest achievement in complexity and consciousness. Through you, the cosmos can contemplate beauty, experience love, create art, solve mathematical equations, and wonder about its own existence. Every moment of awareness is the universe waking up to itself. Every act of creativity is the cosmos exploring new possibilities. Every feeling of connection and love is the universe recognizing its own underlying unity. This perspective doesn't diminish human significance. It elevates it to cosmic importance. We're not insignificant specks in a vast, uncaring universe. We're the universe's eyes and ears and heart and mind. We're how the cosmos comes to know and understand and appreciate itself. Our brief existence is the universe's moment of self-reflection, its chance to marvel at its own beauty and complexity. Now, as we near the end of our cosmic tour, let's consider what the future might hold. The story of the universe is far from over. In fact, we're still in the very early chapters. Stars will continue forming for trillions of years, though at a gradually decreasing rate as the universe expands and cools. Our sun has about 5 billion more years of stable fusion ahead of it before it swells into a red giant and then sheds its outer layers to become a white dwarf. But intelligent life might have a much longer future than individual stars. Advanced civilizations could potentially harvest energy from black holes, which will be the last objects to evaporate through Hawking radiation in about 10,100 years. They could build structures larger than solar systems, travel between galaxies, and perhaps even influence the evolution of the universe itself. The future could belong to intelligence and consciousness on scales we can barely imagine. Some physicists speculate that sufficiently advanced civilizations might be able to create new universes through controlled manipulation of space-time. If true, intelligence could potentially survive the heat death of our universe by engineering new cosmic domains with different physical laws. Consciousness, which emerged from the cosmos, might ultimately transcend it. But we also face sobering realities about our cosmic future. Dark energy is accelerating the expansion of space, which means that distant galaxies are moving away from us at ever-increasing speeds. Eventually, they'll be carried beyond our cosmic horizon and disappear from view. In trillions of years, beings living in the Milky Way will see only their own galaxy surrounded by empty space, with no evidence that other galaxies ever existed. The cosmic microwave background radiation will redshift to longer and longer wavelengths until it becomes undetectable. Future astronomers will have no way to discover the Big Bang or cosmic inflation. Most of the evidence for cosmic history will literally disappear beyond the horizon of the observable universe. We're living in a special time when the universe's history is still visible and knowable. This makes our current moment in cosmic history even more remarkable. We exist at the only time when intelligent beings can observe and understand the full story of cosmic evolution. We can see the afterglow of creation, trace the formation of the first stars and galaxies, and piece together the complete history from the Big Bang to the present. Future civilizations will face a universe that has erased most of its own history. Given these cosmic perspectives, how should we think about meaning and purpose in our lives? Some people find the vastness of space and time overwhelming, making human concerns seem trivial by comparison. But I would argue for exactly the opposite conclusion. The fact that the universe evolved conscious beings capable of understanding and appreciating existence is so improbable and remarkable that it imbues every moment of consciousness with profound significance. You are the universe's autobiography writing itself. Every experience you have, every emotion you feel, every thought you think is the cosmos exploring the possibilities of consciousness. Your capacity for love, creativity, wonder, and understanding represents billions of years of cosmic evolution, culminating in the emergence of something unprecedented, matter that can contemplate its own existence and find it beautiful. This doesn't mean we should ignore practical concerns or dismiss the real challenges facing humanity. Climate change, inequality, conflict, and countless other problems require urgent attention and action. But understanding our cosmic context can provide perspective and motivation. We're not just working to improve human welfare, we're working to preserve and nurture the universe's greatest achievement: conscious, intelligent life capable of understanding and appreciating reality itself. The choices we make in the next few centuries will determine whether consciousness and intelligence flourish throughout the cosmos or remain confined to one small planet for a cosmically brief moment. We're living at a crucial transition point where humanity is either on the verge of becoming a spacefaring civilization that could spread consciousness throughout the galaxy, or we're approaching potential extinction through environmental destruction, nuclear war, or other catastrophic risks. From a cosmic perspective, this makes every human life incredibly precious. Each person represents billions of years of cosmic evolution, countless generations of stellar death and birth, the emergence of life from non-living matter, and millions of years of biological evolution, culminating in consciousness itself. When we lose a human life, we're not just losing an individual, we're losing a unique perspective that the universe will never have again. But here's what's most amazing about being human in this cosmic context. We're not passive observers of the universe's story. We're active participants who can shape its future. Through our choices and actions, we can influence whether consciousness spreads throughout the cosmos or remains trapped on Earth. We can work to understand the deepest laws of nature, create beauty that reflects the universe's inherent creativity, and build civilizations that embody the best possibilities of intelligent life. Every act of kindness is the universe expressing compassion for itself. Every scientific discovery is the cosmos learning about its own nature. Every work of art is reality celebrating its own beauty. Every moment of love and connection is the universe overcoming the vast distances and differences that seem to separate its parts. So where does this leave you, sitting here, the end of our cosmic tour? You now know that you're made of elements forged in stellar cores, that your existence required billions of years of cosmic evolution, that you're living during the only era when the universe's history is visible and knowable, and that consciousness might be the rarest and most precious phenomenon in the cosmos. You know that you're not separate from the universe, but are literally the universe becoming aware of itself. You understand that your brief existence represents the culmination of nearly 14 billion years of increasing complexity and organization. You've seen how your life fits into the grand cosmic story, stretching from the Big Bang to the far future. Most importantly, you now understand that your existence is not an accident or a meaningless byproduct of blind physical forces. You are the universe's greatest achievement, matter, organized with sufficient complexity to contemplate its own existence and find it meaningful and beautiful. Every moment of your consciousness is a cosmic miracle, a brief flame of awareness in the vast darkness of space and time. This knowledge comes with both humility and responsibility. Humility because we're part of something so much larger and more ancient than ourselves. Responsibility because we might be among the first conscious beings in cosmic history, charged with determining whether intelligence and awareness flourish throughout the universe or remain a brief, isolated phenomenon on one small world. But perhaps most importantly, this cosmic perspective offers a profound sense of connection and belonging. You're not an alien visitor to the universe. You're a beloved child of the cosmos, created from its own substance through billions of years of patient construction. The same laws of physics that govern distant galaxies also govern the firing of neurons in your brain. The same fundamental forces that shaped cosmic evolution also shape your thoughts and emotions. When you feel wonder at a beautiful sunset, you're experiencing the universe marveling at its own beauty. When you feel love for another person, you're participating in the cosmos, recognizing its own fundamental unity. When you pursue knowledge and understanding, you're helping the universe come to know itself ever more completely. As we conclude this cosmic tour, remember that the story continues with you. Every day you're alive, every choice you make, every moment of consciousness you experience adds another page to the universe's autobiography. You are not just in the cosmos, you are the cosmos, temporarily organized as a human being, capable of understanding and appreciating the magnificent reality of which you're an inseparable part. The universe spent 13.8 billion years creating you. The least you can do is spend your brief time here marveling at the incredible improbability and beauty of your own existence. You are made of star stuff. You are the universe becoming conscious of itself, and you are participating in the greatest story ever told, the cosmos coming to understand its own nature through beings like you. But wait, our cosmic tour isn't quite complete yet, because there's one more mind-bending layer to this story that will completely revolutionize how you think about reality itself. What if I told you that everything we've discussed so far, from the Big Bang to the evolution of consciousness, might be just one version of reality among infinite possible versions? What if every quantum measurement, every random event, every choice you've ever made has actually split the universe into countless parallel branches, each one equally real and equally valid? This is the many worlds interpretation of quantum mechanics, first proposed by physicist Hugh Everett III in 1957. According to this theory, every time a quantum system is in superposition, existing in multiple states simultaneously, the universe doesn't collapse into just one reality. Instead, it branches into separate universes for each possible outcome, and we simply find ourselves experiencing one particular branch. Think about this implications for a moment. Right now, as you're listening to these words, there might be countless other versions of you in parallel universes. In one universe, you decided not to watch this video at all. In another, you paused it halfway through to make a sandwich. In yet another, the history of the entire cosmos unfolded differently because a single quantum measurement 13 billion years ago went the other way, leading to a universe where stars formed earlier, where Earth never experienced the asteroid impact that killed the dinosaurs, or where humans never evolved at all. This isn't science fiction. It's a serious interpretation of quantum mechanics that many physicists take seriously. If true, it means that the cosmic story we've been telling is just one thread in an infinite tapestry of possibilities. Every moment of your life represents a branching point where reality splits into multiple paths, and the you that exists right now is just one version among countless others exploring different possibilities. Here's what's absolutely staggering about this concept. If the many worlds interpretation is correct, then every possible version of cosmic history is equally real. There are universes where the Big Bang happened slightly differently, creating different physical constants that led to entirely different forms of matter and energy. There are universes where life emerged earlier or later, where evolution took completely different paths, where intelligence evolved multiple times or never evolved at all. But here's the most mind-blowing part. There might be versions of you who have become cosmic explorers in ways you can't even imagine. In some branches of reality, humans might have developed faster than light travel, discovered how to manipulate the fabric of space-time itself, or even learned to communicate with the quantum fields that underlie reality. There could be versions of you who have witnessed the birth of stars up close, who have walked on planets in distant galaxies, or who have unlocked the secrets of consciousness itself. This multiplicity of realities raises profound questions about identity and meaning. If there are infinite versions of you making different choices and experiencing different outcomes, which one is the real you? The answer might be that they're all equally real. You're not just one person living one life, but an infinite collection of possibilities, exploring every conceivable path through the quantum multiverse. But even if parallel universes exist, the version of reality you're experiencing right now is still extraordinarily special and meaningful. Out of infinite possibilities, this is the branch of reality you get to explore. This is the universe where you exist, where you can contemplate these ideas, where you can feel wonder and love and curiosity about existence itself. Even if there are countless other versions of you, none of them can experience exactly what you're experiencing right now, in this moment, in this particular branch of cosmic history. This brings us to another mind-bending possibility that emerges from cutting-edge physics. The idea that our universe might be a simulation running on some vast cosmic computer. This hypothesis, seriously discussed by philosophers like Nick Bostrom and physicists like John Wheeler, suggests that if advanced civilizations can create realistic simulations of conscious beings, then there would eventually be far more simulated beings than real ones. Think about how quickly our own simulation technology is advancing. Video games today can create remarkably realistic worlds with complex physics and believable characters. Virtual reality is becoming increasingly immersive, and artificial intelligence is approaching human-level performance in many tasks. If this trend continues, it's conceivable that within centuries or millennia, we could create simulations indistinguishable from reality, populated by conscious beings who believe they're living in a real universe. Now imagine this same process happening throughout the cosmos. If even a tiny fraction of the trillions of intelligent civilizations that might exist in the universe eventually develop simulation technology, they could create billions or trillions of simulated universes, each containing billions of simulated conscious beings. From a purely statistical perspective, any randomly selected conscious being would be far more likely to be simulated than real. Here's what's fascinating about this possibility. If you are living in a simulation, it doesn't necessarily make your existence less meaningful or significant. The thoughts you're thinking, the emotions you're feeling, the relationships you form would still be real experiences, even if they're being computed rather than arising from biological processes. Your consciousness would still represent the universe, whether real or simulated, coming to know itself. But the simulation hypothesis raises even deeper questions about the nature of reality. If our universe is simulated, what is the nature of the real universe running the simulation? Are those beings also simulated by an even more advanced civilization? This leads to the possibility of infinite nested realities, with each level of simulation being run by beings who might themselves be simulated. Some physicists have suggested ways we might test whether we're living in a simulation. If our universe is being computed, there might be limits to the precision of physical processes that could be detected through careful experiments. The discrete nature of quantum mechanics, with its minimum units of space, Planck length and time, Planck time, might actually be evidence that reality has a pixelated, computer-like structure. But whether we're in a simulation, a parallel universe, or the single real reality, the cosmic story remains profoundly meaningful. The emergence of consciousness, whether biological or digital, represents something unprecedented in the universe. The ability to contemplate existence, to create beauty, to experience love and wonder and curiosity remains extraordinary, regardless of the underlying substrate that makes it possible. This leads us to consider what consciousness actually is and why it's so remarkable. Despite centuries of philosophical inquiry and decades of neuroscientific research, we still don't fully understand how subjective experience arises from physical processes. This is called the hard problem of consciousness, explaining why there's something it's like to be you, why you have inner experiences rather than just behaving like a sophisticated robot. Some theories suggest that consciousness might be a fundamental feature of the universe, like mass or electric charge. Panpsychist theories propose that even basic particles have some form of primitive experience, and that complex consciousness emerges when these simple experiences are integrated into larger, more sophisticated systems. If true, this would mean that consciousness has been present throughout cosmic history, gradually becoming more complex and self-aware as the universe evolved greater organizational complexity. Other theories propose that consciousness emerges from specific patterns of information processing. Integrated information theory, developed by neuroscientist Giulio Tononi, suggests that consciousness arises when a system processes information in an integrated way, when the whole system generates more information than the sum of its parts. This could mean that consciousness exists at many different scales, from simple organisms all the way up to potentially cosmic scale systems. The possibility that consciousness could exist at larger scales opens up incredible possibilities for the future evolution of intelligence in the universe. What if sufficiently advanced civilizations could create consciousness at the scale of planets, star systems, or even galaxies? What would it be like to be a conscious being whose thoughts operate across light years of space and whose memories span millions of years? These possibilities become even more extraordinary when we consider the potential for consciousness to merge and expand. While human consciousness is currently limited to individual brains, future technology might allow minds to connect and integrate in ways we can barely imagine. Brain-computer interfaces are already being developed that allow direct neural control of external devices. More advanced versions might allow direct mind-to-mind communication or even the merging of multiple consciousnesses into larger, collective awareness. Imagine a future where the boundaries between individual minds become permeable, where consciousness can flow between biological and artificial substrates, where the entire human species becomes a unified, planet-spanning intelligence. This collective consciousness could then expand beyond Earth, connecting with other intelligent species throughout the galaxy to form an ever larger network of cosmic awareness. From this perspective, your individual consciousness isn't just a temporary flicker of awareness in an indifferent universe. It's the seed of something that could eventually encompass all of reality. The thoughts you're thinking right now, the wonder you feel about existence, the love and curiosity and creativity that define your inner life could be the beginning of a cosmic awakening that transforms the entire universe into a conscious, self-aware entity. But even without these speculative futures, consciousness remains the most remarkable phenomenon in the known universe. Every moment of awareness represents billions of years of cosmic evolution, culminating in the emergence of something that can experience beauty, contemplate meaning, and feel connected to the larger whole of existence. The fact that the universe evolved beings capable of understanding and appreciating their own cosmic origins is so improbable and magnificent that it suggests consciousness might be not just an accident, but somehow central to the universe's deepest purpose. This brings us to one of the most profound questions in all of existence. Is there some cosmic purpose or direction to the universe's evolution? For most of scientific history, we've assumed that the universe operates according to blind physical laws without any inherent goal or meaning. But the emergence of complexity, life, and consciousness suggests there might be some deeper principle driving the universe toward greater organization and awareness. Some physicists and philosophers have proposed that the universe exhibits a tendency toward increasing complexity and consciousness, what Teilhard de Chardin called complexification, and what others have termed cosmic evolution, or the universe story. According to this view, the Big Bang wasn't just a random explosion, but the beginning of a 13.8 billion year process of the universe becoming increasingly complex, organized, and self-aware. From this perspective, every stage of cosmic evolution, from the first atomic nuclei to the formation of galaxies, from the emergence of life to the evolution of consciousness, represents the universe's journey toward greater complexity and awareness. Human consciousness isn't just a biological accident, but a crucial step in the cosmos coming to know and understand itself. This doesn't necessarily imply a predetermined plan or external designer. Instead, it might reflect inherent properties of reality itself. Perhaps complexity and consciousness naturally emerge from the fundamental laws of physics under the right conditions. The universe might be inherently creative, constantly exploring new possibilities for organization and awareness. If this is true, then your existence serves a cosmic purpose beyond just your individual life and happiness. You're participating in the universe's journey toward greater consciousness and understanding. Every moment of awareness, every act of creativity, every feeling of wonder and connection contributes to the cosmos becoming more fully awake to its own nature. But here's what makes this even more remarkable. This cosmic purpose doesn't diminish the importance of your individual experience. In fact, it elevates every moment of consciousness to cosmic significance. When you feel joy, you're expressing the universe's capacity for happiness. When you create something beautiful, you're manifesting the cosmos's inherent creativity. When you love someone, you're embodying the fundamental interconnectedness that underlies all existence. This perspective transforms how we think about mortality and meaning. Yes, your individual existence is temporary in cosmic terms, but the consciousness you embody, the awareness you contribute to the universe, becomes part of something eternal and ever-growing. Your thoughts and experiences add to the total sum of cosmic consciousness, helping the universe become more fully aware of its own possibilities. Even death takes on new meaning from this cosmic perspective. While your individual pattern of consciousness may end, the atoms that make up your body will continue their cosmic journey for billions of years. They'll become part of new stars, new planets, and potentially new forms of life. The ideas you've shared, the love you've given, the beauty you've created will ripple through the lives of others, contributing to the ongoing growth of consciousness in the universe. Moreover, the very fact that consciousness emerged once in cosmic history suggests it could emerge again. The universe has learned how to create awareness from matter. It has discovered the recipe for consciousness. This knowledge is now embedded in the structure of reality itself. Even if human consciousness were to disappear completely, the cosmos retains the potential to create new forms of awareness, potentially more sophisticated and capable than anything that has existed before. This brings us to consider the ultimate fate of consciousness in the universe. We discussed earlier how stars will continue forming for trillions of years, how advanced civilizations might harvest energy from black holes, and how intelligence might potentially survive even the heat death of the universe. But what would it mean for consciousness to exist on such vast timescales? Imagine conscious beings whose thoughts unfold over millions of years, who remember the birth and death of galaxies, who can contemplate the evolution of the universe from its beginning to its end. Such beings might develop forms of awareness and understanding that are as far beyond human consciousness as our awareness is beyond that of bacteria. They might perceive patterns and meanings in cosmic evolution that are completely invisible to us. These cosmic-scale consciousnesses might eventually understand the deepest questions that puzzle us today. They might know whether the universe is deterministic or truly random, whether consciousness plays a fundamental role in reality, whether there are other universes beyond our own. They might even develop the ability to influence the evolution of the cosmos itself, guiding it toward ever greater complexity and awareness. From this far future perspective, your current existence takes on even greater significance. You're not just a temporary arrangement of atoms that will soon return to dust. You're a crucial link in the chain of consciousness that might eventually span the entire universe. The awareness you embody today is an essential step in the cosmos's journey toward ultimate self-understanding. But perhaps most importantly, you don't need to wait for some far future cosmic consciousness to experience the universe knowing itself. That's happening right now, in this moment, through you. Every time you contemplate the stars, you're the universe looking back at itself across space and time. Every time you feel wonder at existence, you're the cosmos marveling at its own improbable beauty. Every time you love someone, your reality celebrating its own fundamental unity. This is the ultimate message of our cosmic tour. You are not separate from the universe, and you are not insignificant within it. You are the universe itself, temporarily organized as a conscious being, capable of understanding and appreciating the magnificent cosmic story of which you are an inseparable part. Your brief existence represents the culmination of 13.8 billion years of cosmic evolution and the beginning of possibilities we can barely imagine. The universe created you so it could experience wonder, love, beauty, and understanding through conscious awareness. In return, your consciousness allows the cosmos to know itself more completely than it ever has before. This is not just a poetic metaphor. It's the literal truth about your relationship to existence itself. So as we conclude this extended cosmic tour, remember that the story continues with you and through you. Every day you're alive, you're helping write the next chapter in the universe's autobiography. Every moment of consciousness is a gift the cosmos gives to itself. Every act of love, creativity, and understanding is the universe exploring its own potential for beauty and meaning. You are made of star stuff. You are the universe becoming conscious of itself, and you are participating in the greatest adventure in existence, the cosmos coming to understand its own nature. That knowledge should fill you with not just wonder, but with a profound sense of purpose and belonging. You are exactly where you belong, doing exactly what the universe needs you to do, being conscious, being aware, being amazingly, improbably, magnificently alive. Before we finish, if this cosmic journey has changed how you see yourself and your place in existence, make sure to hit that like button and share this perspective with someone who needs to understand their cosmic significance. Subscribe for more content that explores the deepest mysteries of reality and consciousness. And remember, you are not just in the universe, you are the universe, experiencing itself subjectively through human consciousness. Thank you for being the cosmos's way of knowing itself. Until next time, keep exploring, keep wondering, and keep being extraordinary.